how to solve systems of linear equations by substitutions. Example number 1. Let us call the first equation equation 1 and the second equation 2. We are going to solve for either of the two variables in equation 1 or in equation 2. It is easier to solve for y in the first equation. So let us solve for y in the first equation. Y plus 2 is equal to x. Let us use transposition. We are going to transpose positive 2 from the left side to the right side. We change its sign from positive to negative. So we have now y is equal to x minus 2. And then we are going to substitute x minus 2 for y in the second equation. The second equation is 3y minus 5x is equal to 4. We substitute x minus 2 for y. So we have now 3 times the quantity x minus 2 minus the 5x is equal to 4. We apply the distributive property of multiplication to get rid of this parenthesis. So we have now 3x minus 6 minus 5x is equal to 4. We combine similar terms or like terms. 3x and negative 5x are like terms. If we combine them, we get negative 2x. So we have now negative 2x minus 6 is equal to 4. And then we transpose negative 6 to the right side of the equation. We change its sign from negative to positive. So we have now negative 2x is equal to 4 plus 6. This is now equal to negative 2x is equal to 10. To solve for x, we divide both sides by negative 2. So we get x is equal to negative 5. To solve for y, we substitute negative 5 for x in equation 1. Equation 1 is y plus 2 is equal to x. We substitute negative 5 for x. So we have now y plus 2 is equal to negative 5. We transpose positive 2 to the right side. We change its sign from positive to negative. So we have now y is equal to negative 5 minus 2. So this is now equal to y is equal to negative 7. The solution is negative 5 comma negative 7. Let us check. This is the given system of linear equations. This is equation 1. This is equation 2. This is the solution we got. Negative 5 comma negative 7. Negative 5 is the value of x and negative 7 the value of y. What we are going to do is to substitute negative 5 for x in the first equation as well as in the second equation. And then we substitute negative 7 for y in the first equation and also in the second equation. Let us start from the first equation or equation 1. Equation 1 is y plus 2 is equal to x. We substitute negative 5 for x and negative 7 for y. So we have now negative 7 plus 2 is equal to negative 5. Negative 7 plus 2 is negative 5. So negative 5 is equal to negative 5. This is a true numerical statement. Let's go to equation 2. Equation 2 is 3y minus 5x is equal to 4. We substitute negative 5 for x and negative 7 for y. So we have now 3 times negative 7 minus 5 times negative 5 is equal to 4. This is now equal to negative 21 plus 25 is equal to 4. Negative 21 plus 25 is equal to 4. So 4 is equal to 4. This is a true numerical statement. Since we got true numerical statements in both equations, then that means the solution is correct. Example number 2. Let us call the first equation equation 1 and the second equation 2. We are going to solve for either of the two variables in either of the two equations. It is easier to solve for x in the second equation. So we are going to solve for x in equation 2. X minus 3y is equal to 10. Let us use transposition. So we have now x is equal to 3y plus 10. And then we are going to substitute 3y plus 10 for y in the first equation. The first equation is 3x plus 4y is equal to 4. We substitute 3y plus 10 for x. So we have now 3 times the quantity, 3y plus 10 plus 4y is equal to 4. We get rid of this parenthesis by applying the distributive property of multiplication. So we have now 9y plus 30 plus 4y is equal to 4. And then we combine similar terms. 9y and 4y are similar terms, so we combine them. We get 13y, and then we add 30. So 13y plus 30 is equal to 4. We transpose positive 30 to the other side. We change its sign from positive to negative. So we have now 13y is equal to 4 minus 30. We have now 13y is equal to negative 26. To solve for y, we divide the left side and the right side of the equation by 13. And we get y is equal to negative 2. Next, we are going to substitute negative 2 for y in equation 2. Equation 2 is x minus 3y is equal to 10. We substitute negative 2 for y. So we have now x minus 3 times negative 2 is equal to 10. We have now x plus 6 is equal to 10. And then we transpose positive 6 to the other side, change its sign from positive to negative. So we have now x is equal to 10 minus 6. And 10 minus 6 is 4, so x is equal to 4. The solution now is 4 comma negative 2. Let us check. This is the given system of linear equations. This is equation 1 and this is equation 2. This is the solution we got, 4 comma negative 2. 4 is the value of x, negative 2 is the value of y. What we are going to do is to substitute for x in the first equation and also in the second equation. And then we substitute negative 2 for y in the first equation and also in the second equation. Let us start from equation 1. Equation 1 is 3x plus 4y is equal to 4. We substitute 4 for x and negative 2 for y. So we have now 3 times 4 plus 4 times negative 2 is equal to 4. This is now equal to 12 minus 8 is equal to 4. 12 minus 8 is equal to 4. So 4 is equal to 4. This is a true numerical statement. Let us go to equation 2. Equation 2 is x minus 3y is equal to 10. We substitute 4 for x and negative 2 for y. This is now equal to 4 minus 3 times negative 2 is equal to 10. We have now 4 plus 6 is equal to 10. 4 plus 6 is 10, so 10 is equal to 10. This is a true numerical statement. Since we got true numerical statements in both equations, that means the solution is correct.